All right, today we're jumping into something really cool, and honestly, pretty critical for anyone building intelligent enterprise systems. We're talking about the CognOS Event Fabric, which the source material describes as nothing less than the nervous system for enterprise AI.
So let me just start by asking a question, especially for all you architects and developers out there. How do your AI systems actually see and react to what's happening in the world, right now, in real time?
Because, let's be honest, if you're like most organizations, your systems are trying to make sense of a total patchwork of different signals, and that creates blind spots and, frankly, a whole lot of brittleness in your architecture.
And this gets to the heart of what the source material calls the enterprise AI signaling problem. So let's really unpack the challenges that come from having all these disconnected, fragmented event systems.
I mean, just think about your own setup, right? Your events are probably all over the place. Some in Kafka, others in log files, a bunch more in different monitoring tools. You have no single unified view of what's going on. So what do? You build these one-off, ad hoc triggers that are incredibly fragile. Governance is inconsistent at best, and you end up with these huge audit blind spots, because the signals just disappear after they're used.
So, how do we fix this mess? Well, the source material proposes a totally new way of thinking about this.
And here it is. It's called the CognOS Event Fabric. The idea is to think of it as the reactive nervous system for your intelligent systems, a single, unified, and observable plane where all events can live and be understood.
Now, this is where the thinking really shifts. The goal here isn't just to handle events. As this quote puts it, it's about turning those raw, fleeting signals into a living, queryable network of cause and effect. You're not just processing data, you're building an intelligent graph.
Okay, that sounds great in theory, but how does it actually work? Let's break down the core concepts that make this whole thing possible. It's actually super elegant. First, you have an event, some immutable fact that just happened. That event travels on a governed channel we call a stream. Then, a pipeline can jump in to filter it, or aggregate it, or transform it. And when a trigger condition is met, bang! It fires an action. It's a really clear, structured path from signal to action.
And here's the best part for all you developers watching. This whole life cycle is defined declaratively. We're talking simple, straightforward YAML files. That makes this whole system incredibly easy to build and manage.
So let's make that tangible. This is a perfect simple example of a trigger. You can see we're watching a stream called metrics rolling. The condition is super clear. If the 5-minute average latency goes over a certain threshold, boom. After a 15-minute cooldown period, the action is to kick off a recovery workflow. It's readable, it's powerful, it just makes sense.
Okay, so when you put all this together, it builds towards 3 pillars that every single enterprise architect obsesses over: governance, observability, and resilience. This slide just lays it all out, doesn't it? It's the move from that fragile, opaque patchwork we started with to an intelligent substrate that is governed by design, is observable and explainable right out of the box, and is genuinely resilient and adaptive. I absolutely love this quote from the source material. Policy is by construction, not bolted on. Man, that is so important for any serious enterprise system. Governance isn't an add-on you worry about later. It's woven right into the DNA of the system from the very beginning. And how do they pull that off? Well, with real concrete features, a central registry for all your event types and streams, so no more guessing, policies for retention and access control that are actually enforced at every step, and get this, safety guardrails like storm breaks to stop runaway processes in their tracks.
And then there's observability. It's not an extra you have to configure, it's just on, by default. Your events become queryable facts. That whole network of cause and effect we mentioned, you can visualize it live. For debugging and just understanding what your AI is thinking, that's a game changer.
Right, so all of these things, the governance, the observability, the resilience, they're not just features for feature's sake. They all serve one big goal: building AI systems that you can actually trust.
But let's be specific. Why is this kind of system so critical for AI workloads in particular?
Well, for AI, this gives you real clarity. You know the exact signals that made an agent do something. It gives you control. You can put budgets on autonomous actions or set up human-in-the-loop approvals. It allows for true adaptation, managing those complex feedback loops so the system can regulate itself. And most importantly, it builds trust by creating this permanent, queryable record of cause and effect for audit and analysis.
So when you boil it all down, the real power here is this. It's about replacing the dozens, literally dozens of fragmented systems you might be cobbling together today with just one.
One unified model, a single, consistent way to think about events, streams, and pipelines that just works everywhere, across all your different business domains, your processes, your AI agents. That consistency, that's the bedrock for building trustworthy AI at scale.
And that leaves us with the final question you should probably be asking about your own setup. Is your AI built on a solid, coherent nervous system, or is it still running on a fragile, reactive patchwork?